True world simulators require robust dynamic memory and object permanence. When an object leaves the screen, it should not just vanish or freeze. It must continue to exist and move in 3D space so that when the camera pans back, the object reappears exactly where it should be. WorldDirector achieves this by acting as a digital director, coordinating both camera and object movements to maintain a persistent world state. Current generative video models fail because they entangle physical dynamics with pixel rendering. Standard models rely on implicit memory within their neural weights. When an object is occluded or exits the frame, the model quickly forgets its appearance and trajectory. This leads to trajectory collapse, frozen states, or completely altered identities when the object attempts to re-enter the scene. WorldDirector solves this by decoupling semantic motion planning from visual synthesis. Instead of forcing the video generator to guess physics, WorldDirector uses a large language model to plan 3D trajectories and camera movements first. These abstract 3D plans are then projected into 2D bounding boxes, serving as deterministic location conditions that guide the video generation process. Precise control is maintained through dual conditioning of location and appearance. The model uses two distinct conditioning maps. First, a location condition encodes the precise spatiotemporal trajectories of objects using color-coded masks. Second, an appearance condition injects sparse RGB features from historical frames, acting as visual anchors to preserve the exact identity of re-entering objects. A temporal drop mechanism prevents the model from simply warping static images. If the model always has access to dense appearance references, it tends to lazily slide or warp the image. To force natural, articulated motion, WorldDirector drops most appearance frames after the initial entry, keeping only one reference every 6 frames. This forces the model to synthesize realistic movement based on text prompts and trajectories. Quantitative evaluations show that WorldDirector significantly outperforms existing world models in reconstruction metrics like PSNR and SSM. More importantly, it maintains exceptional subject consistency, ensuring that characters do not morph or change clothes even after prolonged periods out of view, proving the effectiveness of the decoupled planning approach. The primary limitation of WorldDirector is its reliance on synthetic training data. Because real-world video datasets with precise 3D annotations are scarce, the model is trained on synthetic game engine data. This introduces a domain gap, occasionally resulting in unnatural locomotion or slightly blurry faces. Future work aims to bridge this gap using real-world datasets. By separating high-level planning from low-level rendering, we can build highly controllable, persistent virtual worlds. Users can direct complex, long-horizon events with multiple characters, paving the way for next-generation interactive simulators, virtual reality environments, and AI-driven filmmaking.